Namaste student. Today we are going to prove root p plus root q is a irrational number if p and q are prime number. The last class we have seen that root p is an irrational number if p is a prime number. We'll use that concept and we'll prove this problem. So the way we have taken in last class, let root p plus root q be a rational number. Then by definition we are using here contradiction method. Okay, then by definition of rational number, p plus root p plus root q equals to a by b, where HCF of ab equals to 1. Okay, now you take one of them, any one. You can take p or q in that side. Okay, so we are keeping our p this side and we are taking our root q in the right hand side. So the symbol changes, a by b minus root q. Now what you will going to do? So what we are going to do? Step squaring both sides. If you square both sides, you can see here this will give you p and this one will give you a square by b square plus q square minus 2ab. So here we are using squaring both sides. Now look at here, we are getting root q, which is what? Prime number. In the last class theorem we have proved. So our target is that bring your what? Irrational part one side and rational part another side, and then we'll contradict. Okay, so this one will bring this side, so it will give you 2a by b root q, and this will, if we take the LCM, a square plus q square b square by b square, and bring this p this side, it will give you minus p. Okay, next step, take the LCM, so you are getting a square plus q square b square. LCM will give you b square and multiply with this minus p b square, and bring this 2a at the denominator place and b here, means cross multiplication. So root q will remain this, the whole thing will be multiplied with b, and this 2a will be here 2a. Now look at here, what you can see by last class theorem, we can see that this is our left hand side. Root q is an what? Irrational number. But what? But RHS, that is a square b multiply plus q square bq minus p bq by 2ab square is a rational number. That means this contradict our assumption. Hence we can say that root p plus root q is an irrational number. Now the question will arise, sir, how could you say that this is your rational number? Let's see. Here we have already told that a and b are what? Integer. Now look at here, and this is p, inside p is a prime number, that is also an integer. Q is also an integer. Okay, now square of integer is integer. This is your integer multiply this integer with this, it will give you integer. Next part, q square is your integer, bq is also an integer. Multiply of two integer will give you integer. Minus p is also an integer, bq is an integer. Multiply two integer will give you integer. That means addition of two integer is integer, difference of two integer is an integer. That means upper part numerator is your integer, similar denominator is your integer. So one more definition is there, that if both are integer and if we write in the form of a by b form, that means you can say that this is your rational number. And in last class we have seen that root q, where q is a prime, is an irrational number. Then how could it possible that one side is rational and another side is irrational? It's not possible. Where is the mistake? Here, what we have assumed? We have assumed that this one is rational number. That's why this contradiction arises. That means our assumption is wrong. So we can say that whatever we have assumed, that is totally wrong. So we can say that root p plus root q is an irrational number. Okay. Thank you.